Okay, for homework 9-7, I'm going to have you copy all this work and then the words to show me that you listened. So here we go. Got 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so I want you to do the sequence work for this pattern. That first one listed, that is after the first hour or after the first day or the very first term. That second one is the second term and the third. Never make that first one the zero term by mistake. If you're thinking that's zero term, you're mistaken. You could use that to find the zero term though. This is going to be 3. 1, 2, 3, 4, 5, 6, 7, 8. This is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Those are my key numbers right there that I'm looking for. Knowing that these numbers at the bottom, those are my X numbers. I need you to backtrack to that all-important zero term by doing the opposite. I can see up on top here, I'm adding by 5. Adding by 5. That is my common difference number. We call that D. D is 5 for common difference. The first random word is soccer. Soccer. Always arithmetics where you're adding have a common difference. You could use that to backtrack, to go backwards, subtract that. And again, you're using these terms. 13 minus 5 is 8. 8 minus 5 is 3. This 3 minus 5 is what I'm looking for. 3 minus 5 gives me negative 2 for the all-important y-intercept term. If I wanted to write recursive, I use this equation right here with that common difference number. So if I want to write the recursive function for this data, I would write the plus 5 in there. That recursive function matches this data. If I want to use it, for example, to find that fourth term, remember, all it is really taking this 13 right there, the number of x's before the fourth term, and knowing that I'm adding 5. So all I got to do is take that 13 plus 5, 18 right there. There will be 18 x's. To find that fifth term, keep going. 18 plus 5, 23. That's using the recursive pattern, using the one before it and knowing that you're adding 5. Use the number before it and know you're adding 5. That's the recursive pattern. To actually use that, here's how it looks. To find that fourth term, I'm going to put in 4 right here. In that recursive equation next to that, I'm going to put that 4 inside here. That gives me the fourth term comes from me looking at the one before it, the value of the third, and adding 5. Looking at the value of the third, I got 13 x's there. So that number replaces this. So I want to find the fourth term. I replace that f of 3 with how many x's there really are, 13, and I add that 5, and that will give you full credit showing the recursive pattern, how to get 18 out of that, knowing that those are all coordinates. So recursive is used to find the one right next to each other in a pattern. You don't need to use a formula. You know the one before it, you know the number that you're adding. All you got to do is add that number to the one before it. The only hard part though is when you're trying to show this math. Like for example, if I wanted to find the fifth one, I use the f minus 1 plus 5, gives me the fifth term, comes from the value of the one before it plus 5. The value of the one before it, I look up at my table and see at f of 4, there were 18 of those. So if I add that to that 5 already, that tells me that at the 5th term, there's going to be 23 of those squares. All right, if you're jumping ahead to maybe the 30th term, now you got to use the explicit function. Second word is volleyball. Volleyball. All right, the explicit, which is used to jump ahead, is always f of x equals that number in front of x that you're adding or subtracting, 5x, plus the y-intercept term. This one is going to be a negative, so I make sure I write minus 2 right there. And again, if you want to prove to yourself, see if that equation works. Plug in 3, see if you get 13 out of that. Should. Plug in 3 right there. Gives me f of 3 equals 15 minus 2. There she is. Third term is 13. Supported that math right here. This is the point 313 right there. All right, to find the 30th term though, I'm going to replace that x with 30. Gives me the 30th term is 150 minus 2, or at the 30th term, I'll have 148 x's, following that pattern. Knowing that if I graph these, they graph straight lines because this is arithmetic. This is x. These are all my days or my numbers. This up here, my f of x, that was number of x's right there. And then again, if you graph this straight line, following that same over 1 up 5 slope, over 1 up 5 if you were to graph it. All right, third word is dog. Dog. Hopefully this helps a little bit. We'll keep practicing. Good luck.